Assalamu alaikum my dear students. Welcome to chemistry class C1. We are starting with unit 1 experimental chemistry. This is for week number 7, 18th May 2020 to 22nd May 2020. And the subtopics to be covered in week number 7 are measuring physical quantities, measuring mass, measuring time, measuring temperature, measuring volume, methods for collecting gases, drying gases. And resources for this week will be your chemistry book Christopher and Prescott, unit 1, page number 1 to 7. Educational videos are also given and you can also consult chemistry matters. Discussion and explanation of the topic is done through audio and visual aids. Diagrams are also given for more conceptual clearance. Educational videos are also provided at the end of the lesson, which will be helpful for better understanding of topic. When the topic will be completed, a homework assignment is also given which you need to solve. And the objectives of this lesson: by the end of the lesson, the students will be able to name appropriate apparatus for the measurement of time, temperature, mass and volume, including burettes, pipettes, measuring cylinders and gas syringes. Students will be able to suggest suitable apparatus given relevant information for a variety of simple experiments, including collection of gases and measurement of rates of reaction. Now the introduction. In order to communicate effectively, scientists all over the world use the International System of Units (SI units) as a common standard for their measurements. In laboratory, measurements are usually carried out to find the following: mass of substance, volumes of liquids and gases, temperature of substances, time taken for reactions. Over here, one of the term is SI units. SI stands for System of International Units. And in chemistry, that is use the modern metric system to measure quantities of different things. That is called International System of Units. We use the metric system in everyday life. For example, speed is measured in kilometers per hour and rice comes in sacks of 5 kilograms and 10 kilograms. In order to communicate scientific information easily, scientists use SI units as a common standard for their measurements. Now we will discuss the apparatus for measurement. Stopwatch that measures time, accuracy nearest second. Electronic balance measures mass, accuracy up to 0.001 gram. Triple beam balance that measures mass, accuracy nearest 0.1 gram. Now I want to tell one thing over here, that all these measurements are called quantitative measurements because that gives result in definite form, number and units. Now the next is thermometer that measures temperature, accuracy nearest 0.5 degree centigrade. And next is the gas range that measures volume of gas produced and accuracy is nearest 1 centimeter cube. Now the next is measuring volume of solution. Number 1 is measuring cylinder that holds either 100 or 250 centimeter cube. It means the capacity of measuring cylinder is 100 to 250 centimeter cube. It can hold the liquid up to 100 to 250 centimeter cube. Its accuracy is nearest 1 centimeter cube. The next is burette that can hold 50 centimeter cube. That is graduated, and in this the liquid can be of 50 centimeter cube. Accuracy is nearest 0.1 centimeter cube. The last one is pipette that holds 20, 10, 20 or 25 centimeter cube, and that can only measure fixed volumes. And the next is volumetric flask. Volumetric flask is used to measure fixed volume of large amount of liquid accurately, and it is accurate to 0.1 ml, for example 100 ml, 250 ml. Volume of gas during a reaction. The apparatus given below in this diagram that is used when gas is produced during a reaction. As gas escapes, it fills the space in the gas range. By measuring how fast the syringe is filled, the speed of the reaction is determined. Now the next is measuring mass. The SI unit for mass is the kilogram, kg. Common apparatus used to measure mass is electronic top pen balance, measures up to 0.01 gram. Over here, now what is mass? We know mass is the quantity of matter in an object. and the mass of the substance is measured with a beam balance or an electronic balance, and usually we use electronic balance. Often very small masses of substances need to be measured in chemistry experiments. So in such cases, an electronic balance with an accuracy of up to 0.01 gram is used for precise and fast weighing, and the SI unit for mass is the kilogram. Smaller masses are measured in grams, and in industry the tons is used to measure the masses of heavy objects. Now for example, 1 kilogram is equal to 1000 grams and 1 ton is equal to 1000 kilograms. Now the next is measuring volume. The SI unit for volume is cubic meter, and commonly used units for volume in laboratory are centimeters or decimeters. That is, 1 decimeter cube is 1000 centimeter cube. Now what is volume? Volume is the space occupied by that substance. We know this. Now the SI unit for volume is cubic meter. The cubic meter, the cubic centimeter and the cubic decimeter are also used, which are the smaller values. And in order to convert 1 cubic meter, that is equal to 1000 decimeter cube, and 1 decimeter cube is equal to 1000 centimeter cube. Now there is a question, how do we measure volumes of liquids? We know that scientific experiments often involve liquids, and the figure over here that shows some of the apparatus which is commonly used to measure the volume of liquids. One of the apparatus is beaker and the other is measuring cylinder. The different apparatus used have different degrees of accuracy. The apparatus we use for an experiment depends on the volume we are measuring and how accurate we need the volumes to be. Now the next is measuring volume liquids. Common apparatus used to measure volumes of liquids are given over here. We have already discussed some of the apparatuses. The first one is beaker, that is used to estimate volume of liquid. Measuring cylinder, more accurate than beaker, measures up to 0.1 centimeter cube. Pipette, used for measuring fixed volumes of liquids accurately, for example 20 centimeter cube, 25 centimeter cube and 50 centimeter cube. Measures up to 0.1 centimeter cube accuracy. The next is burette, used for measuring variable volumes of liquids accurately, measures up to 0.1 centimeter cube. So, from all this discussion, we can conclude the volume of a substance is the amount of space it occupies, and in the laboratory it can be measured in various ways. Approximate volumes of liquids can be measured in a graduated beaker. For greater accuracy, a measuring cylinder, or for very accurate measurements, a pipette or burette may be used. A volumetric flask is used to measure fixed volumes of liquids and is used for preparing solutions of known concentrations. Now the next is same topic, measuring volume liquids. Solutions when placed in a glass container will form a curved surface called a meniscus. Means when we place the solutions in any of the glass container, that can be your measuring cylinder, that can be your burette. The solution will form a curved surface that is called a meniscus, just like shown in the diagram. If the meniscus is concave, read of the scale at the bottom of the meniscus. That in case of concave meniscus, you have to read the reading from at the bottom of the meniscus. If the meniscus is convex, read off the scale at the top of the meniscus instead. Means in case of convex meniscus, and that is usually formed in colored solutions. Means when the solutions are colored, in that case convex meniscus is formed. And in order to read off the scale, you have to use the top of the meniscus. Measuring volume gases. Gases can be collected and measured using the setup shown below. This is the diagram which is used for measuring the volume of gases. Common apparatus used to measure volume of gases, that is gas syringe, measures up to nearest centimeter cube and able to measure a maximum volume of 100 centimeter cube. So we can say over here that volumes can also be measured using syringes. Small plastic syringes are used for measuring small volumes of liquid. Such syringes are used by doctors for injections, and larger syringes are used to measure volumes of gases. Volume is usually measured in cubic centimeter, though larger volumes may be in cubic decimeters or liters. Now this is the diagram of the setup for an experiment involving gas collection. You can see in this diagram that conical flask is fitted with the gas syringe, and in the conical flask there is the reaction mixer, and if the gas is produced, that volume can be measured by using gas syringe. Now the next is measuring temperature. The SI unit for temperature is Kelvin. The commonly used unit for temperature in laboratory is degree Celsius. Common apparatus used to measure temperature, that is mercury in glass thermometer, and its accuracy measures up to nearest degree centigrade. Now the temperature of a liquid or gas can be measured using a thermometer. We know this. It is measured in degrees Celsius. Commonly we use the thermometer in which the common unit is degrees Celsius. The mercury in glass thermometer and alcohol in glass thermometer are common thermometers. That instead of mercury in glass thermometer, there is another thermometer which is alcohol in glass thermometer, that is also used in the laboratory. Electronic thermometers are increasingly being used. Instead of mercury and alcohol, there is the third one, that is the electronic thermometers. They are also used because they reduce the risk of mercury poisoning if a mercury thermometer is broken while in use. Now the next is measuring time. The SI unit for time is second, and common apparatus used to measure time, that is digital stopwatch, measures up to 0.01 second. Very important point over here, that in the laboratory a stopwatch or stop clock is used to measure time. Two types of stopwatches are there. One of the stopwatch is analog stopwatch, while the other is digital stopwatch. Analog stopwatch that can only measures the nearest second, that measures timing to the nearest second. But there are very accurate stopwatches just like the digital stopwatches that can measure to 0.01 second, that hundredth of a second. It means digital stopwatch is more accurate as compared to analog stopwatch. Now let's discuss the next topic, collection of gases. The method used to collect a particular gas depends on: is the gas more or less dense than air? Is the gas soluble in water? All gases can be collected using a gas syringe. If a gas is less dense than air, it can be collected by upward delivery. If a gas is more dense than air, it can be collected by downward delivery. If a gas is not soluble or only slightly soluble in water, it can be collected over water. When a gas has been collected, it can be tested. Now we know that chemistry is an experimental science. We may need to plan and perform experiments to learn more about reactions. So it is very important to select suitable apparatus for the experiment, number one. And we know that in some experiments gases are given off, and these gases can be collected and identified, and they help us to find more about the reactions that have occurred. The gases may also be collected for use in another reactions. So methods for collecting gases, that depends on the physical properties of gas. Number one is the solubility, how soluble the gas is in water, and number two is the density, how dense the gas is compared to water. So there are three methods of collecting gases. The number one is the collection of gas by downward delivery, the collection of gas by upward delivery, and collection of gas by displacement of water. When the gases has been collected, then there are various tests to identify the gas. Now first of all, let's discuss the displacement of water, that is collection of gas by displacement of water. The apparatus shown is suitable for collecting gases that are insoluble or slightly soluble in water. Carbon dioxide, hydrogen or oxygen can be collected by using this method. Over here in the reaction mixer, just like we are taking zinc and hydrochloric acid, and the gas which is produced, that is the hydrogen gas, that is collected in the gas jar by the downward displacement of water. Now the upward delivery. For gases, this method is used for gases which are soluble in water and less dense than air. For example, ammonia. Ammonia can be collected by upward delivery of gases, and this experiment we cannot use it for the collecting of hydrogen, although the hydrogen is less dense than air, but that is not soluble in water. So the previous experiments, that is hydrogen, can be collected by only displacement of water. Now the next is downward delivery, that the collection of gas by downward delivery. This method is suitable for gases which are soluble in water and denser than air. For example, chlorine, hydrogen chloride, sulfur dioxide. And there is a special note for carbon dioxide, as carbon dioxide is heavier gas, denser than air. So carbon dioxide gas can also be collected by the downward delivery. As the carbon dioxide falls out of the delivery tube and into the gas jar, it pushes the less dense air out of the top of the gas jar. So this method is also called the upward displacement of air. Collecting dry samples of gases. Now let's discuss how to collect dry samples of gases. We can dry a gas by passing a drying agent through them, as these agents will absorb the moisture. We know that the drying agents, they absorb the moistures, and the common drying agents, they are concentrated sulfuric acid, quicklime, formula is calcium oxide, and fused calcium chloride. One very important point, that concentrated sulfuric acid is used to dry moist gases like chlorine and hydrochloric acid. However, it cannot be used to dry ammonia because it reacts with ammonia. Over here we know this, that concentrated sulfuric acid is a drying agent that absorbs the moisture. So if any of the moist gas is present, then we use the drying agents to dry them. But in case of sulfuric acid, we cannot use it to dry ammonia because ammonia is an alkaline gas and it will react with the sulfuric acid. So in order to dry ammonia, we cannot use concentrated sulfuric acid. Now the figure shows the three sets of apparatus and the chemicals used to dry gas. In diagram number 1, concentrated sulfuric acid is used to dry moist gases including chlorine and hydrogen chloride. However, it cannot be used to dry ammonia because it reacts with ammonia. In diagram number 2, quicklime calcium oxide is used to dry gas, and the gas which we used to dry by using quicklime is ammonia. In the third diagram, fused calcium chloride is used to remove all the traces of water, and it can be used to dry most of the gases. Now the recap. The method of collecting a gas depends on the density and solubility of the gas. Displacement of water is used for collecting gases that are insoluble or slightly soluble in water. Downward delivery is used for collecting gases that are soluble in water and denser than air. Upward delivery is used for collecting gases that are soluble in water and less dense than air. The last point, we can collect a dry sample of gas by passing the gas through a drying agent such as concentrated sulfuric acid, quicklime or fused calcium chloride. Now here are given some of the video links. Click on these links and watch the videos for more understanding of topics.